this is Mrs. V, and this is our calorimetry lab in case you were absent or on distance learning. So right now what we're doing is we're going to determine the specific heat, and today we're going to work with copper. So remember, heat transfers, right? As soon as something gets in contact with another substance, it will become that temperature. They become at an equilibrium. So they pass energy back and forth until they end up with the same amount of energy, which ends up being the same temperature. So I want you to look over here. So over here you should see we have our samples, okay? And this is copper. And so I have around 40 grams of copper in each of these tubes. I'll give you the exact weight when we start, but I have it heating up, and you notice, you may not see it, but it's starting to bubble. I'm waiting for it to get to 100 degrees Celsius, and so I'm going to take this temperature really quick. We're going to see where we're at, but once it gets to 100 degrees Celsius, then what we're going to do is we're going to leave it in there so that everything becomes an equilibrium. So I want you to start thinking, if Mrs. V leaves that in there for 10 minutes at 100 degrees Celsius, what temperature would the copper be when I take it out, okay? Remember, it's going to pass it back and forth until they are at equilibrium, or that they are equal temperatures and not passing energy back and forth, okay? All right, so we're going to let this kind of get up. It's about at 86, and then I'll get back to you with our next steps. Okay, so this is our first step. We're waiting for that to boil. It's almost there, and we'll let it sit there in for 10 minutes. So the first thing I want to do, though, is I want to get the beginning mass of the water, because remember, our specific heat capacity also depends on mass. So I've got my scale here. I've pressed 0. We're at 0.0. So the first thing I'm going to do is I'm going to put, when I do the water, it's really hard to measure water, but I'm going to put my styrofoam cups here, and I'm going to zero it out. What that does is it takes off the weight of the styrofoam cups. But one thing I want to know is, what is the mass that I'm starting with for the water? So I'm going to go ahead and pour all my water back into my cup, and I'm going to record this. So the water that we're starting with that goes in your data table is 167.2 grams. So remember, depending on the mass, how much stuff we have is going to depend how fast everything gets spread around, because the more stuff or atoms that we have, the more energy we need to heat them up. So when we're doing our calculations, remember that specific heat is in joules per gram per Celsius. So we need a mass to figure it out. So in your table, please put our beginning mass of our water is 167.2 grams. All right, so we have to also know what temperature our water starts at. So we've measured the mass of the water, and now this is our temperature. Let me see if I can get it. So our beginning temperature of our water is 23.8 degrees. So that's our initial temperature of our water. Okay, so here we are in our next thing is we've started to boil. So I want to take the beginning temperature of my boiling water. And this, remember, after 10 minutes will also be the beginning temperature of what that is sitting in here. So I'm going to take the temperature. I'm going to get a little closer so you can see, hopefully. It's a little bit unclear, but I'll show it to you when we're all done. There we go. That's a better angle. So I'm just going to take the temperature to know what we're starting at here, so we can know what our change in temperature will be. Because this will be, remember, what temperature is the copper getting to if it's sitting in, and it looks like it's at about 100.2, okay? So we're going to stay at 100.2, and then we will take that out, and I'll show you what our next step is. Okay, so we have about 7 more minutes here with our boiling water. I'm put my goggles on so in case it splashes, I don't want to burn my eyes. And then I have my cup here, and what I've done here, I'm going to move your camera here, and what I've done here is this is just a cup of water that we put, we measured the mass in, and I just put it in a beaker just so that it's a little more stable when I work with it. So I'll see you in about 6 minutes when we actually put our copper, which remember, it's in 100.1 degree water for 10 minutes. So what happens with the temperature and the energy, when you leave them together at the same temperature, what's going to happen to the temperature of the copper? What's that beginning temperature of copper going to be when it's been sitting in something that's passing energy back to it and heat and temperature? What is it temperature going to be after 10 minutes? All right, so we're back. All right, back, and we got about 20 seconds left on the timer that this is going to sit in for 10 minutes. And then after that, what we're going to do very quickly, you'll see in just a second, starting to really boil. I'm going to put it down so our glass doesn't break. But what's going to happen is I'm going to transfer it into this cup. And there's our timer. Okay. So once I transfer it, I'm also going to seal this up with some plastic wrap and then put the thermometer in there. So think about, why would I put wrap on there? What am I trying to prevent from happening? Okay, the other thing I want you to realize is, I'm going to show you in just a second, but we're going to get the weight of the copper, which I have on the top of the tube. So I'm going to grab my copper. I'm going to do this very quickly. So why would I have to do it quickly, right? And I'm going to grab it and put it right on into the water here. And then I'm going to quickly try to seal this up as best I can. Okay. And I'm going to let it sit. Okay. And so then I also want you to realize this is 40.4 grams. So 40.4 grams of copper. And while I'm waiting, I'm also going to poke a hole through my plastic wrap so I can put my thermometer in there. Now notice I'm putting my thermometer away from the glass because the glass will be hotter. And I'm going to go ahead and turn this off so we don't break our glass. And then what we're going to do is we're just going to wait. And we're going to wait and see what our final temperature is going to be. And once it kind of stops moving, I'm going to turn this towards you guys. Okay. Once it stops moving, for a few seconds, I will tell you what that is. Okay, so now again, we just wait. Okay, we're back. We've let this sit here for 5 minutes. And so I want to show you that the highest temperature it's reached is, see if I can get it, 25.3. So this is our equilibrium temperature. So what does that mean? What temperature is the copper now inside the test tube? So our final temperature is 25.3. All right, after you've done all this recording, now it's time for you to go to the calculations. And if you get confused, please email me and let me know. See you next time.